Today, we're not just building an application, we are forging a shield, an architectural shield. We're going to dive deep into the core patterns for scalability and resilience on Google Cloud that make sure your application can withstand, well, pretty much anything, from massive traffic spikes to entire zone outages, all without missing a single beat.
And that quote just says it all, doesn't it? In these critical systems, failure isn't some minor inconvenience. It's an absolute catastrophe. When every single millisecond counts, the ability to scale and stay resilient isn't just a nice-to-have feature. It's the whole foundation. So, the big question is, how do we build something that's truly unbreakable?
Well, our first step is to really understand the enemy, downtime. Before we can justify building this kind of sophisticated defense, we need to know exactly what we're up against. We have to quantify the cost of failure, because only then does the investment in real resilience start to make a whole lot of sense.
You know, it's funny how percentages can be so deceiving. 99% availability sounds fantastic on a spec sheet, right? But just look at what that actually means. That's over 14 minutes of your system being completely down every single day. Now, let's just move from 2 nines to 3, a tiny 0.9% improvement, and bam, you slash that downtime to under 90 seconds. See? This isn't just a number. It's the difference between a daily crisis and a minor blip on the radar.
Okay, so how do we build for that much higher standard? We forge our architectural shield from 3 absolutely critical pillars. You can think of these as the essential alloys that, when you combine them, create a defense that is both incredibly strong and, surprisingly, flexible.
So here they are, the 3 pillars of our shield. First, automation. This forges the foundation, making it consistent and strong. Then there's loose coupling, which acts like a series of interlocking plates, making sure that damage in one spot doesn't shatter the whole thing. And finally, data-driven design. That's our watchtower, letting us see threats coming and react before they can strike. Let's break down that first one.
First up, automation. Look, building a complex, scalable system by hand is kind of like trying to build a skyscraper by hand. It's slow, it's inconsistent, and it's just begging for mistakes. Automation is all about creating a repeatable, totally reliable process that takes the single biggest variable out of the equation: human error.
So how do we automate? Well, we start with something called infrastructure as code, or IAC. This just means your entire environment, your servers, your networks, everything is defined in a simple text file, just like your app's code. It gets versioned, it's repeatable, and it becomes the one and only source of truth. Then we add the principle of immutable infrastructure. Now think of it this way. We never repair a running server. Nope. If it needs an update, we destroy it and replace it with a brand new, perfect instance built from a master image. These 2 strategies working together completely eliminate what we call configuration drift, and they make sure every single deployment is flawless and predictable.
All right, let's move on to our second pillar, loose coupling. I want you to imagine a shield made from one single solid sheet of metal. One strong hit, and a crack can just spread across the entire thing, shattering it completely. Now, imagine a shield made of smaller, interlocking plates. One plate might get damaged, but the rest of the shield, it holds firm. That right there is the whole idea behind a loosely coupled architecture.
So, to build that shield of interlocking plates, we design our system not as one giant, single thing, a monolith, but as a collection of independent services. Each one talks to the others through a clear, simple contract, but none of them are directly dependent on the messy inner workings of any other service. That independence, that is the secret sauce to resilience.
And this slide really shows you that choice in stark terms. Over on the left, you've got the monolith. Its services are chained together like dominoes. If that last one in the line falls, they all fall. But on the right, the services are parallel. They operate independently. So if one of them fails, the others can keep on chugging along. The system might have some reduced functionality for a bit, sure, but it doesn't collapse.
And hey, if you're not convinced, just look at the math. This is where it gets kind of crazy. If you chain 2 services that each have 99% availability, your total system availability actually drops to just over 98%. But if you run those same 2 services in parallel, where one can fail without taking the other one down, your aggregate availability jumps to an incredible 99.99%. Your architecture itself has a massive, massive impact on your reliability.
Now, we get this loose coupling with a few key patterns. We use microservices to break that big monolith into small, focused pieces. We design them to be stateless so any server can handle any request, which is absolutely crucial for scaling. We put in a circuit breaker pattern, which is like an electrical fuse that automatically isolates a failing service. And finally, we enforce all these boundaries with clean, well-defined APIs.
So we have an automated, loosely coupled system. But how do we know if it's healthy? That brings us to our third and final pillar, data-driven design. This is the sentinel, the watchtower that is constantly monitoring the health of our shield, looking for any sign of weakness or stress.
We don't guess, we measure. And according to Google's site reliability engineers, these 4 golden signals tell you pretty much everything you need to know about your service's health. Latency, it tells you if it's fast. Traffic tells you if it's busy. Errors tell you if it's broken. And saturation, basically how full it is, tells you if it's about to break. I mean, if you can monitor these 4, you can basically predict the future.
And this data isn't just for looking at on some pretty dashboard. It's for making promises. We use it to create what are called service level objectives, or SLOs. So, for example, using our latency signal, we can set an SLO like this. 99.9% of all homepage requests must be served in under 200 milliseconds. See, this isn't some vague goal. It's a hard, data-driven target that now dictates all of our engineering priorities. So, our shield is forged. It's built with automation, it's loosely coupled, and we're monitoring it with data. It's designed to withstand failure. But resilience isn't just about surviving damage. It's about adapting to pressure. What happens when a million users show up all at once?
This right here is the fundamental challenge of scalability. If you provision for your peak traffic all the time, you are wasting a fortune on servers that are just sitting there idle. But if you don't provision enough, your users are going to have a terrible time during a rush. So, how do you get it just right?
This is the classic expensive trap of over-provisioning. You're paying for all the capacity you might need at your absolute peak, but as you can see, most of that power just sits there, doing nothing, burning money. There has to be a smarter way.
And on Google Cloud, we have an incredibly powerful toolkit for exactly this. We use auto-scaling on services like GKE and Compute Engine to perfectly match our server capacity to real-time demand. For services that have spiky, intermittent traffic, we use serverless platforms like Cloud Run that can literally scale down to 0, which eliminates costs completely when they're not being used. And for massive global demand, we use global load balancing to scale to the moon, distributing traffic intelligently all across the globe.
And with that, all the pieces are on the board. The automated forge, the interlocking plates, the watchful sentinel, and the dynamic core. So let's assemble our complete architectural shield.
So here it is, the architectural shield. Its foundation is automation, which gives us consistency. Its structure is made of loosely coupled components, which contain failures. Its awareness comes from data-driven observability, so we always know exactly what's going on. And its strength? Well, its strength is its ability to flex with dynamic scaling, making sure it is always perfectly balanced between power and efficiency.
Your shield is ready. It's strong, it's resilient, and it's efficient. But a shield is only as good as the army that wields it, right? What happens when you need to put these powerful, complex patterns into the hands of thousands of developers across a huge enterprise? How do you make sure everyone's consistent and prevent complete chaos?
Well, that is exactly where we're headed next. We're going to explore the ultimate force multiplier, the Enterprise Developer Platform, which is a system that makes all this power simple and accessible for every single team. It is the key to scaling resilience itself. You are not going to want to miss it. Until then, stay resilient.